Right now, since I found the microphone, well, I want to first off say thank you to the ESIIL program for allowing us to participate this summer. I can't say enough how I appreciated the opportunity to learn myself this summer on a couple Python as an API and enter programming language. And thanks to Elsa, you're dynamite. I hope you don't get swooped up from a private sector person, you know, because you have a lot of knowledge, just like Nathan and James does too. So again, I just want to say thank you for you guys sponsoring this program and Jennifer for your due diligence to have this program for us, for all of us in here, not just my school, but to give the opportunity for the students that I got to work with and the other students that from the respective schools. But today I want to introduce you guys to Jeremy Maker, Carlina Bennett, and Julius Hosteller and Jason Slick. Now, my students are the ones like you see on the slide here. Two of them are at TOCC, and one of them is in San Carlos. But I want to clarify Julius works underneath me under the tribe, and he handles a lot of the air quality stuff for the tribe with me. So he's, I guess, my student and staff technician. So he does a lot of work with me on that. Now, you might ask, why do you have two sister institutions? There was agreement through the tribes, through San Carlos and Tohono O'odham Nation, that when the school was being formed, that they formed an agreement to have the accreditation go under the Tohono O'odham Community College, and San Carlos would be a sister institution. They are in the process of going through their own accreditation as we speak, right as of right now. But that's how we have San Carlos as a sister institution to Hana Autumn Community College. So my four students will be presenting today. I'm just going to go over the first few slides here. And first off, we kind of had two projects when we started this project. Oops, I'm sorry. Let me go back. Oops, how do I go back? Okay, sorry about that. Let me go back. Why is this? Okay, wait a minute. This is not okay. Okay. Oh, my Mac is acting up today. Don't do this to me. Okay, there it goes. Okay. We originally started off our project with two different projects that's on the San Carlos Reservation dealing with our water quality and our air quality. But after further research and work we did, we kind of focused our energies on the air quality. So when we're doing the monitoring the environmental impacts of air quality on the San Carlos Apache Reservation, we decided to kind of go in that realm, but the water quality data that we'll be showing you in our presentation um, has a correlation to our air quality and a correlation for future research that we're going to be doing. So, our research question was, how is air quality being impacted by environmental factors such as the road proximity, population density, and drought? We wanted to focus on the air quality for this project. Our goal is to understand how the factors of roads and population density affect air pollution. And the tools we used were purple air sensors, maps, and we did a risk analysis that you will see further in our presentation. Now, our project, we wanted to focus on our air quality sensor data that is on the reservation through Purple Air right now and focus on the sensors that we could get the data from. We focus most of our measurements on particulate matter 2.5 microns. We do have the measurements of the 10 micron level, but we wanted to kind of go in more depth about the 2.5 microns. That's a little bit smaller than your hair follicle. If you want to kind of visualize what that measurement is. So it's air particles that's smaller than your hair follicles. So don't pull out a hair follicle and look, whoa, but that's what we wanted to kind of factor our measurements on our air quality and temperature and humidity. One other thing, we looked at the air quality proximity to our roads and population density around the different districts of the reservation. And we looked at the risk analysis doing the environmental risk score, which is part of our risk analysis. Okay, next slide. And next slide, this will be Julia's. Julius, where is he at?
Oh, yes, I'm here.
Okay, go ahead.
Okay, so for our purple air, before we started using purple air, I seen the demonstrations of how Mark introduced purple air to me, and we have made, well, supposed to be five, but four are online right now for the air monitors in four locations in the res. And it was pretty interesting. And we have that website online, all those four monitors, three of them, or actually two in San Carlos, one in Paradise and one in Vilas. There's supposed to be one in Qatar, but it's not yet online. So this was pretty interesting when um uh like 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 everyone says, shout out to Elsa for helping us out for the purple air maps of how to type out the code for purple air. And it was pretty interesting how it really showed out. Or
Oops.
am I am I cutting?
You're muting yourself.
Wait, does this
Now you're good, Julius. Go
You're
ahead.
good.
does did I did I tell the whole explanation or
Well, you were just on the shout out with Elsa and about how she helped us with the API Purple
oh
Air
yes.
Python interface.
Yeah. Yeah, it was pretty interesting and I was like playing around with Google Collab, and Google Collab was pretty helpful, especially with Gemini. Gemini, even though it's kind of a little bit annoying, but it did help with the coding.
All right. So next slide. See, come on, work today, please. Okay. All right. This is Jeremy.
Okay, so we wanted to make sure that we had some visuals of where the sensors were within the reservation. So our first task, we had to decompose that into a couple different steps. Our first task is to get the coordinates, latitude and longitude of the reservation. So that's what the map on the left represents. And then the next step was to actually map out the four sensors that are online currently. And so that's what the map is on the right. So you see there's three that are actually pretty close together.
It's a love-hate relationship. I agree.
And then one that's further out. And we'll actually share some interesting data a little later as we go on. But we had to use different types of coding techniques like GeoPandas. We use OpenStreetMaps for these geospatial tools. Okay, next slide.
Okay. Julius.
Okay. I'm trying to see the or wait, give me one sec, guys. I'm still new with this. Okay. All right. All right. What is PN 2.5 and why it matters? So we're in the middle of the fire season with all this here. Not it's not just the fire season, but it's also with like what do you call that part? Illegal burnings. We're dealing with illegal burnings in our reservations. And well, they basically have a permit for it, and it is required to have a permit if you burn something. And there's a there's a coding that someone has to be aware of of what they're burning. So in our reservation, we were dealing with burnings. Either they don't or they do have a permit in the reservation. And plus we have a lots of elders too in our reservations. So this will be effective to their respiratory system. And I mean, I dealt with those type of stuff a lot, but then again, it's a risk for every elders in the community. Let's see here. Okay. Yep.
All right.
That's all I have.
Okay. Go ahead, Jeremy.
This one is Carlina.
Oh, Carlina, I'm sorry. I I can't see when I'm in presentation mode. Sorry, Carlina. Go on and jump in.
Hi. Okay, so air quality trends over time. This was collected hourly over 7 days. When we had presented last week, the ones that are closer together, there was one that was a higher risk score, but now that had changed and moved to the southern one. Line graphs to observe changes, higher PM 2.5 during specific times of the day.
Next. Next slide.
Okay, so as she mentioned, we reran the code last night. So on the bottom, you'll see the actual dates for when the data was pulled. So it's recent within the last 7 days. This top graph, and we're going to show you the interactive features of it here at the end, but we wanted to give you an overview now. This top graph has a couple different data points that is very interesting. On the left-hand side, you have your average PM 2.5 levels, and then down across the bottom, you have your hours of the day. So, and it's in a 24-hour time format. So the 15 would be 3 o'clock. The blue solid line that goes across, this is all sensor data, and it's an average during this time period for the last 7 days. So on average, at 5 o'clock in the morning, it's pretty low for the PM 2.5 levels. As we come over here to about 1 o'clock in the afternoon, on average, all sensor data considered, we see more of a peak. And then you can kind of see the peak time. Now, the purple kind of shading area, those are data points as well. But again, the blue line is the average. The purple represents the variability. So where you don't see little to no purple at all, the data over that time is very consistent. It's almost the same each day at that specific time. But the more purple you see, the more variability you see. And then down here below, it's a 4 sensors that are online. That's what the solid light blue, solid orange, solid yellow, and solid green lines represent. You see that one of the sensors are spiked. We're going to look at that a little bit more here in just a little bit. And then you also see a kind of light green dashed line. That is the EPA annual standard. And then a kind of light yellow dashed line. That is the EPA moderate threshold. Next slide, please.
Analyzing proximity to roads, hypothesis, closer sensors equal higher pollution, map roads and calculated distance, found correlation between distance and PM 2.5. Population density, pulled data from the US Census, estimated density near sensors higher densities equal more activity and possible more air pollution.
So looking at these sensors and the data that it was pulling, we wanted to take a look at some different things that could affect the air quality. Obviously, PM 2.5 is a big part of that, but also the closer it is to roads, that is going to likely have an effect on the air quality. And the same with higher levels of population. And so each one of these are given a score from 0 to 100. And it's broken down with the PM 2.5 having the largest impact, with it having a 50% rating or 50% weight. Proximity to roads would be 30% weight, population would be 20% weight. And so taking a look at this, you see that the dots that are close, the sensors, and the dots that are closer together, they're really light. And so they're on the right-hand side, the legend there shows that the environmental risk score is quite low, and likely not huge areas of concern. But this one over here is really dark, and so it's going to be up here. That one is a concern to discover what is causing the anomaly there. Next slide, please. So going a little bit into more depth with the environmental risk score, PM 2.5 level, as we mentioned, was a 50% weight. And that is because it's the #1 deadliest air pollutant, according to both the EPA and the WHO, having a very direct health impact. The road proximity, 30%, it's a major pollution source. It's known that pollution is 2 to 3 times higher near roads, and population density, according to our sources that we researched and pulling these different weights, it's weighted at 20%. More people affected obviously equals a higher community risk, and we did cite our source at the end of the slide for that. Next slide, please. EPA data. So you can see where our current average is, and that's taken all the sensor data again. Overall, the average is quite low, but the highest reading is definitely up there. But then you take a look at where the EPA annual standard is and where the EPA moderate threshold is, and you still see that there's definitely some room for work and some deeper digging into these readings here. Next slide, please.
Oh,
PM 2.5 levels obviously are going to vary by location, just by nature. They also vary by time. And so when we were looking at that graph that showed the solid blue line as the average, but then also showing spikes, there's many different things that could contribute to that. And again, that's over a 7-day period. Some of those days would have been during the work week, some would have been over the weekend. So days when there is more traffic, maybe rush hour, that type of thing, we would expect the levels to be higher. So they are going to vary by location. They're going to vary by time. By location, closer to roads, higher pollution, population areas show a moderate elevation. And then the environmental scores show some areas where we can do some further digging. Next slide, please.
this would be Jason. We'll go over this.
All right. These are the different these little icons are the little different water testing sites, and some are the river. Some are near the border of the reservation, and some are the ones that are grouped up in the middle are mostly around the San Carlos area. Next slide. What this means: environmental data shows real concerns. Tools help uncover hidden patterns, can guide health action, policy, and awareness. This is a map of the San Carlos and the drought conditions. And I had also put up some information last night, and as of July 22nd, approximately 95% of Arizona is under drought conditions. And also as of July 18, the tribal council in San Carlos declared a state of emergency for San Carlos because of extreme droughts. Next slide. Tools and technologies used. Python libraries, GeoPandas, OSMNX, HBplot, Pandas, requests. We also use ArcGIS for mapping, data sources, Purple Air, US Census, OpenStreetMap. The visuals were maps, time series, and correlation plots. Next slide. Challenges and lessons learned. API limits and request timing. Geospatial data joining took learning. Some sensors lack data. We learned API environmental data and visual storytelling.
Okay, our next two slides kind of wrap it up, and we'll come back to those for a minute, but Mark's going to quit sharing his screen for a minute, and I'm going to take over sharing so I can go over some of the interactive maps briefly.
Good. So let me go over the future work. Which we are going to be doing is looking at more of the water quality sensors, study seasonal trends, use models for prediction, and integrate community feedback dealing with the water quality sensors that we want to look at, and correlate it with the issues of the drought that Jason said. And this proclamation from the chairman was also on our local news here in Arizona as well, on the local 12 news, because I was headed out to work and they announced it. And I was like, uh-oh, okay, we're headed to work. That means something important there. So the area where we're at, we're under a lot of drought contingency issues that's going to affect our water. Therefore, it correlates to our air quality that we're presenting to you guys too. So I'm going to let Jeremy go into the Google Collab right now. Let me go here. And we'll come back to the questions and thank you here in a second. Let me escape. Going ahead, I'm gonna start my share. Jeremy, you can go in and show the Google Collab to how we did our interactive part.
Okay, so on the screen here, there's lots of code that went into this, so I won't really go over that, but you can kind of get a glimpse of the coding there. But what I do want to show you is the same images that you just saw on the slides, but the interactive part. So whenever these are the sensors here in the border of the reservation. And whenever you move your mouse pointer over it, it gives different information like longitude, latitude, the average PM 2.5, the environmental risk score, the name of the sensor, which is very important because we needed to figure out the correlation here. And then distance to a road as well, which tied into the score, the environmental risk score. So this one here is very similar to that one. It just gives some different indicators. So the green is EPA compliant, yellow is an EPA violator, red is highest EPA violator. This one here shows proximity to roads. So these blue lines are all roads within the reservation. And so you can see that these sensors are quite close to the roads. And whenever you move your mouse over it, then it tells the distance to the road. So again, this one is the highest one, this one on the far right. And then when we come here and we look at the spiking sensor here, that is that same sensor, has the same name. And so that one is the one that spiked. You do also see, though, that it dropped back down. So I think that that is something to pay attention to. It went very, very high, but then it came back down. And you can see from the trend, we could have taken that maybe out to 14 days or 21 days to see what the trend was before that, but it was spiking up before it came back down. And then this is just more information of the air quality versus the current readings versus the EPA standards. And whenever you hover over it, it just gives you the PM 2.5 actual reading. So that is the interactive maps. And I will stop sharing. And I will turn it over to Mark to bring the slide presentation back up and Carlina to close this out.
Okay, sorry about that. I was just getting text by my boss, so I'm sorry. But anyway, this is what the particular project we decided to do, and if there's any questions, let me pull up what I had here. Um, what what we came out of this is learning how to do API and Python interface functionality with Purple Air. I don't think that particular work has ever been done. And what we found out is with the help of Elsa and Nathan that is the Purple Air has changed their interface of gathering data and how to get archival data. Now, one thing I don't think we articulated, and one thing our sensors that we picked up were only from the Purple Airs that were published open source onto the Purple Air website. We have the one that was mentioned in our presentation in Cutter, but we're having an issue with the device getting onto the network of that site where we have it at, and it's going through IT protocols with that particular department. However, we are finding out by having these sensors, we're getting more community awareness. There's more people involved with understanding what the problem with air quality is. And now we're getting into indoor air quality issues. And that's what Julius and I are going to be working on here coming into the fall. Even though we're still in fire season, our fire season does not end until September. And we are in the range of 108 to 115 degrees right now as we speak this week. Our temperatures and relative humidity is really low, and that's the reason why we brought the facts up about our drought problems and what Jason went over. Now, a lot of people will like say, well, how isn't drought just mainly related to water, and how does it relate to air? As you all know, if we dry up and there's no water, then you have arid lands, and it can be a dust bowl, basically, just like how a lot of the agriculture things happening back in the Dust Bowl era with, I don't know, what the early 20s and 30s. I could be wrong on those time dates. However, that's what we're running into at San Carlos is that factor of vegetation drying up because of the drought that we're having. Farming is needed to be changed the way with the use of the water and how the area is, especially around that point that Jeremy brought up. That was Bilas in the lower southeast corner that we're having. There's a lot of farming going on, new construction in that county, as well as the waste management. It's the border town Safford, but the landfill is out towards that way as well. So we have all of different things going on. That doesn't even include the mines that are around the borders of our reservation coming. We have mines all around the border of the reservation from the northwest side, west side, southwest side, all the way down to the southeast corner of our reservation. So there's a lot of different things that were happening. And when we were picking up this air quality data and doing the data analysis that Jeremy just went over and did the code, that was something brand new. And I'm very proud of what my students did and found that information out. Jeremy did a lot of legwork on some of the programming as well as Jason. Carlina helped out with this beautiful presentation and a lot of collection of our source information. The source, though, we use this source to talk about our air quality monitoring and how it affects our community. So in other communities as well, and how we do the modeling with the machine learning and stuff. So this is what we use to reference our work. Are there any questions or anything for us? I don't think there's any in the chat.
Mark, there's one in the chat from Brandy who's asking, did you have the opportunity to visit any of the Purple Air sites to see the measuring device?
Oh, yes. Yes, that was Julius and I were on site to see that. And we were out there doing a lot of the monitoring of those devices. And what we're using is the Purple Air Flex 2 device, which if you go to the Purple Air site, and they have two different types of outdoor air sensors, but we were using the Flex Air 2 Purple Air sensor, the newer ones that they have. um, we just got another one that we have online that we're dealing with the IT security issues to hit to the network. But that one's we're using an EPA older Purple Air, where we have a partnership with the EPA. We have another. Do you think? How do you say the dual diurnal? So not urinal. Sorry. How do you pronounce that?
Diurnal. Jennifer.
Aired here.
Sorry,
Diurnal,
Jennifer.
the I was struck by the hourly pattern in the PM 2.5 figure where I think y'all said it started at like 5 a.m. that you started to see the increase in the PM 2.5. I was just curious if you think that expansion that happens during the day and later in the afternoon is related to wildfires burning more or more intensely, or what you think might be driving that kind
Well,
of daily pattern.
I'm just gonna give my little 2 cents in here. So far, we've been blessed because of the fire restrictions that the reservation, our forestry department has placed on the reservation. However, we've had surrounding wildfires, and like the one that was just north of us on the outskirts of the reservation. There was one in White Mountain Apache Reservation that was going on, and we had the downdraft smoke of that coming down in our community. The wildfires in the Grand Canyon that's not even contained yet as we speak. There was the Oak Ridge fire that was near my family. I appreciate a lot of you guys from ESIIL looking out for me, giving your prayers and blessings, because that fire was literally 5 miles from my mother-in-law's house. So, with that being said, with this particular data research that we did, that I think is a precursor of what the importance of air quality and how wildfire season happens, especially when we couldn't get the data yet, but there was the only oldest sensor we have is at the college, and there were about 2 or 3 years ago, there was a big 2 or 3 big wildfires that happened, and there was a lot of problems where people could not evacuate. I mean, it was on the western side of the border of the res, and a lot of the. Let me just. Okay, so when I mean the western, I'm talking about this side over here where you got Globe and Miami. So 2.5 years ago, there was 3 major wildfires, one on the reservation, two in Miami and Globe. So the fires were blowing up this way, and it was going this way. There's a major road that comes this way that I take every day to work, but a lot of people had to go through the Salt River Canyon, go the back way up to White River on the res roads that are not paved to try to get out, or go through Safford or go through Tucson for evacuation. And it's really tough, being that evacuation ways to get off because of wildfires. It's very, very dry right around in here where we have our air sensors. The lake is just south of here. You see this little green where I have my cursor at? That's approximately where San Carlos Lake is. Then we have our TOCC Lake, which is man-made up here. That's just about right in here where my cursor is. I know you can't really see that, but those are only are two of the main lakes on the reservation that are main water sources. What I mean by that is they are dammed up, used for livestock and uh, drinking water. My job, we handle with the sites that was mapped by Jason. Um, let's see here. These sites that was mapped by Jason is where we in our department are the water sites that we do our measurements for the Clean Water Act that all over that we measure. So for certain contaminants, and right now, being that we have drought, there's also other algae buildup. There's also other things we're dealing with that it's crazy. I don't know how else to explain it and concerns that we have as a community. And this past week I was in dealing with the RTOC meeting with the EPA, which was just ended yesterday. This research that we found out is very vital to the community as well as other communities, but St. Carlos community is vital where a lot of people are wasting water. I mean, a lot of our districts do not pay attention. And when I go out to speak about air quality, I have to put their perspective into how COVID hit because it's so multi-generational families and don't understand how the importance of the air quality. So that's my analogy where I have to explain the indoor air quality plus the outdoor air quality. And when we do have wildfires, it's even worse because you have the smoke, then you have the wind blow, and everything's dry. So you have the combination of all that particulate matter going on at the same time, Jennifer. And a lot of people do not know, they don't have adequate HVAC systems. They're still using evaporators or swamp coolers, however you want to call it. So those get sucked up when, like Julius was talking about, illegal burns. We've had people call us and complain about people doing illegal burns and burning diapers and all kind of other stuff in the trash. So it goes into the swamp coolers, goes in their home, and it's just nasty. Um, and right now, my job is to get this aware to the community and establish more sensors. We don't have, we purposely put, and why this research was done about the population density and proximity is because this is where a lot of our population is in the districts and a lot of the air quality where a lot of people are living. And therefore, this picture here, when we talk about environmental risk, that's where a lot of population of San Carlos live. This is Bylis down here in the southeast corner. And then you have Peridot, which is I call it industrial corridor, where they're doing a lot of construction stuff at the hospital, plus homes and some other businesses are popping up there. Then we have this area where the colleges and then forestry, which sits kind of on, it's called 7 Mile, which kind of sits on top of a mesa where their headquarters are. So yes, when it's wildfire season, it's crazy. We have our hot shots up there that is from forestry, and Julius actually went with me. Um, they had a youth forum while we were doing this work, so he kind of explained some of the work what we're doing with Python in air quality to those students this summer as well. Sorry to be drawing out your answer to your question, Jennifer, but yeah, it's not a pretty sight. All we can do is really get the awareness out. And by doing this type of research, it's really going to help us to get the information out better.
Awesome. Thank you, Mark and Jeremy and Carlina and Jason and Julius for all of your hard work. Mark, you have one more question in the chat from James about interest in the college developing tribal partnerships through a drought plan. I'm going to have you answer that one in the chat, Mark, so that we have enough time for people to get through the other three presentations. But give it up for San Carlos Apache College and Tohono O'odham Community College for their hard work.